Let's go ahead and start with a different function this time. This time we'll go ahead and start with f of x is equal to the square root of x. And the square root function looks like this. It starts at 0, 0, and goes off to the right. So this time we're going to go ahead and talk about horizontal transformations. Horizontal transformations are the right or left, and they actually do the opposite of what you would think. So if you ever have f of x and it is changed to f of x minus some number, that actually goes to the right. An example of that is my f of x function would be the square root of x minus 3. And the easiest way to see why this change is different is think about what would happen if I plugged in 0 here. If I went ahead and plugged in 0, that would give me a negative number underneath the square root, which is imaginary. So think about this as finding where is the x-intercept. So where does x minus 3 equal 0? That happens at 3. So that's why this gets moved over here. So that subtraction sign actually moves this function over to the right. If I had the same function where it was f of x was equal to the square root of x plus 3, that would move it over to the left. Again, think about this is where would that give me 0? So that would be over here at negative 3. So when you're having these transformations, they're moving either left or they're moving to the right, depending upon what is going on with this. So if you want to remember which way to reflect the negatives, remember you're flipping over the same axis. So instead of flipping these left or right, you're taking this piece of paper for a negative transformation and flipping it that way. So go ahead and take this and flip this left, right. And that's what would happen when you have those negative values. All right, so what does that look like mathematically? What we're talking about here is that is always going to be an inside the function, everything notation. So that is going to then become f of the negative square root of x. Same thing down with this function. That would be f of x would equal, and again, I'm changing the negative only for x, so that would be negative x minus 3, and this one would be negative x plus 3 for all of those functions. That x value is what is changing inside there. So if I start with my original function, f of x, where x is the input and y is the output, the input value changes for the same output. So what I mean is that the y values in this case will be staying the same, but what changes is the x values. So if you are translating this to the right, remember, a right translation is you are subtracting. So for the same y value, x changes. And x changes by that same amount that we've done this translation. So in this case, it would be x plus whatever that d is, and that y value would stay the same. if it was a translation over that was, if we have a translation the other way, and again, this is your translation where you are actually adding, it does, the horizontal change does the opposite of what you were doing. Inside here, it would be subtracting whatever that value was around the y. And if it was where you're taking the last one and it was f of negative x, then that x value would just change its sign. We're going to go ahead and do a couple of examples with these next. All right, so looking at my graph here, we're going to talk about how to change these points. So the first one we're going to go ahead and do is, let's talk about a translation that is f of x plus 1. Now remember, this means it's going to the left 1 unit. So if I start off with all of the points that I have in my graph over here, these points are -4, -2, 0, 2, 2, 2, and 4, 0. So if I start with this set of x values and y values, the change that happens to these is that for the same y value, the x value gets shifted. As we start with the y values, I'm starting with the y values of -2, 2, 2, and 0. What changes take place to the x? Remember, with this, you're going to the opposite one. So this is going to become -4 minus 1, or that new point is going to equal -5. The next one would be 0 minus 1, or -1, 2 minus 1, or +1, and lastly 4 minus 1, which is 3. So all of this is just going to get shifted to the left one. Let's go ahead and do those points. That's going to be 5, -2. The next one will be -1, 2. Then finally 1, 2, and 3, 0. So that is what that graph would look like. I can't emphasize enough that whenever the operational change is inside the function, you're doing the opposite of that on the inside. So what is a horizontal transformation? Remember, when we're doing these, it means that you're changing the inside of the function. Everything that you change on the inside goes horizontally or left to right, and all of your y values will stay the same. What changes are those x values. So if I look over here on the left from my graph, those points that I have are -4, -2, 0, 2, 2, 2, and 4, 0. So all of the y values that we have here, those are going to stay the same. What's going to change, though, are all of my x values, and those all get multiplied through by a -1. So that changes this 4 to a positive. The 0 doesn't change. 0 or -0 is the same, so we don't really need that. Then -2, and a -4. Now, this, if you can imagine taking your sheet of paper and flipping it over that same axis. So as you're taking this piece of paper and you're moving, I'm talking about a horizontal change, you're talking it going from left to right. So you are going to flip this from front to back, or to go ahead and flip it from left to right. And that's what that graph is going to go ahead and look like when it gets flipped. Again, we just flipped it left to right. Left to right is horizontal change. If it was vertical, that would be up, down. So let's just go ahead and check these to make sure everything's right. So this point, the first point that we have is right here. That is my 4, -2. And then this point is still 0, 2. That one stayed the same. And yes, this point right there, that is -2, 2. And lastly, -4, 0.